Hi, my name is Chaitanya Lakeshri, and in this video, I will be showing how to download SWMM5 source code and how to compile it. And once you compile the C source code for the SWMM engine, I'll show you how you could debug the application or how could you debug the SWMM5 source code. So first you need to do is you need to visit the EPA website. You could just type SWMM5 um, on the Google and just search for it. Go to the official website of EPA, and over here you have the source code section. And from this section, you need to download the computational engine zip file. And I will click on it and will just download the source code, and it will download the source code over here. What I will do is I will extract the source code. Click extract. This will extract the source code. And once you have done that, after that, what you need to do is you need to open Visual Studio Code. You need to download Visual Studio Code. Visual Studio, sorry, not Visual Studio Code, but Visual Studio 2022, or if any latest version is available, you should download that. You could just Google Visual Studio and it will take you to a Microsoft website. So Visual Studio is a IDE developed by Microsoft. You can download the free community version. If you're using it for any commercial purpose, you should purchase a license and use Visual Studio in that scenario. But I will just click on free download, and once you do that, uh, you should run the installer, but I won't do that. I have already installed it on my machine. So if I go to Visual Studio installer, you will have a window similar to this particular window. And if I click on modify of any of the, yeah, so this is the window which you will see. What you need to do is you need to click on desktop development with C++. This will install the C and C++ compiler developed by Microsoft, and which could be used with this particular IDE. IDE stands for Integrated Development Environment. This IDE helps you in writing the code, um, finding any issue before compiling the code. It helps you identifying any issue while compiling the code, and also it helps you in debugging. So just click on this part, development C++, and I think you should be good to go. And another thing which you need to um, make sure that you have clicked on checked on C++ make tools for Windows. So this will be necessary because if you open the download that source code for SWMM5, you see there is this thing called a cmakelist.txt, which means it has a C make project uh, associated with the source code. So therefore, we will need this particular CMake tool for Windows. Close this, but what you need to do is you need to click on install. So sorry. So you need to click on this and then click on install. And if you're interested in Python or any C++, C sharp uh, development, you can close as well. Okay, and so I'll close this, close the installer. And your next thing is you need to, once you are done with the installation, you need to open Visual Studio. So once you're done with the installation, you need to open Visual Studio. And before you do that, like, this is how the start screen will look like. So before you open any project, this is how the screen will look like. What you need to do is open a Visual Studio project or any any programming project in C plus Visual Studio. You need a solution file for Visual Studio, and that is what we are going to do right now. We will create a solution file. So once you have Visual Studio installed on your machine and you have downloaded the source code for your SWMM engine, what you need to do is you need to open this readme text and follow through these 3 steps mentioned over here. First, you need to do is what you need to do is press Windows and then type developer. Okay. Developer command prompt. So this prompt of developer command prompt will be installed on your machine when you install Visual Studio Code. What I will do is I'll just click on this and it will start this command prompt. Now I need to change the directory of this command prompt. So I'll copy the path and I will type cd and then control V, paste the path. So now my current directory for this command prompt is the folder where the source code is present. So this folder contains the source code. So now, according to the steps mentioned in this particular file, what we need to do is we need to create a folder called as build. What I can do is I can just right click and click on new folder and type its name as build. But like what I can do is I can type this command mkdir, which stands for make directory, and then the name of the directory, which is build. If I hit enter, you could see it will create a new folder over here. Next step is to change a directory to that particular folder. Okay, now our current directory is build and I'm inside this particular folder. The next step is to enter these 2 commands, but to enter the first command, which is cmake -g, then the compiler name, and then the platform name. So for this, what you need to do is you need to identify which compiler you are using. So over here we have some notes. So the name of the compiler should be inside double quotes. So I'll just copy and paste this path, and then you need to enter the version of your Visual Studio code. Sorry, code Visual Studio. So for me, it is 17. How do I know that? I can go to help and then click on about Microsoft Visual Studio. Over here it says version is 17. Therefore, I'll write 17 over here. Yes, 17. And I know this is 2022 because if I open the application, it says 2022. So that is the product name and this is the command. And in platform, we need to add the appropriate platform for which we need to build the application for. So I'm building this application for, so I'm not building the application, so I'm compiling the source code to a 64-bit application. So I will use x64 instead of 32-bit, but you can use 32-bit as well or Win32, sorry, for a 32-bit application. So you can write Win32 I want a 64-bit application, so I will copy this. I'll paste it. So this is my command. I'll copy this command, entire thing, and I'll go to the developer command prompt which we had opened and our current directory is built. I'll paste it over here and I will hit enter. Now you can see it is creating certain files inside this build folder. It has created all these files. Most important file which it has created is .sln file, which is a solution file. And if you double click on it, it will open Visual Studio Code. So I will close Visual Studio Code. I will just double click on it and it has started Visual Studio Code. Okay, so this is your SWMM5 source code. And what we will do right now is we will build it right away. Okay, so if I right click on this particular folder and I click on the right build, it will build this particular project. So there are 4 projects in total. So when you build the all build project, right click, and if you click on build, it will build all the projects contained inside this particular solution. What we need to do is we just are interested in this 4 projects. When you build SWMM5, it will actually build the um, source code for the engine. And then run swim is a application which uh, the source files have. This is a example application. If you double click on it, it has just one file, which is main file, and it will run this. This is the entry function, and this is what it will return. It will return 0 if it is able to successfully run the code. So it just contains one single main.c file. Okay. Instead of this, you can write whatever code you want. This is not related to the source code. The actual source code is related stored in this particular folder, which is SWMM5. If you click on the source files, you will see all the source files. So there are dependencies. So if I right click and build this particular project, it will not run successfully because it depends on this particular project. So the output of this project is um, what required for running the run SWMM project. So what I will do is I'll just right click, I'll click on build and it will start the build process. So every C file, it is creating a object file. And if I go over here in the build folder, so this is our build files for the current project. So just show you guys, I will delete it and I'll just split the screen and I will rebuild the project. Okay, or I'll build this particular project and you would see all the files are getting created. The moment I run this particular project, it will create certain files. The next thing is we want to run the run swim project. Okay, and another thing is in the source, I guess no. Okay, x64. Let's see. No. Let's build a run swim project. Okay, if I click on build, it will create another folder and let's see what's there in this particular folder. Yeah, so this will build the run swim folder, but you could see that there is no exe file to run the application or the build files, so that will most probably be in this particular folder. Yes. Okay, so I will just delete these folders again. Okay, if I rerun the SWMM5 project, you could see it will create the DLL files. Okay, SWMM5.dll. So this is your actual uh, EPANET, oh sorry, SWMM application, all the functions which are associated with the source code and with the engine, all the things are stored in these four files. Okay, and when I run this particular project, which just consists of one main.c file, that is when it will create a exe file. So these two files are dependent on these four files. That is why before you build this particular project, you need to build the SWMM5 project. Okay, now let's run the exe file. If I double click on it, okay, it will start a command line and you won't see anything happening. It will immediately close. So for that, what you can do is just type cmd, okay, and let's run the project from cmd so that we can capture what is happening if the application is throwing any error. Okay, so that is saying not enough arguments given, because when we run this particular application we need to give it uh, three arguments, and which includes inp file, then out file path, and then report file path. So I will just open couple of files on my machine, okay, just and copy them over here. Okay, so I have this particular model called as site drainage. I don't have a INP file for that, so I will copy this one. Okay, let's copy the inlet drain model and paste it over here. I'll just copy the name of this particular project, and what I'll do is I will type run swim and then name of the INP file. Again, I want to create a report file, rpt file, which will have same name, but the extension will be .rpt space. Again, same name, and the extension would be .out. And when I hit enter, it will create rpt files and .out file, which means we were successfully able to download the SWMM source code, build a command line application, and using command line application, we were able to run the simulation. Okay, so this is how you run um, your SWMM source code. And now I will show you how to debug your application. Okay, and so I will just close this, maximize the window. So I'm running this particular program, and I will just hit a breakpoint over here. Let's see, I'll hit a breakpoint at this particular location, and I will click on this particular button. But if I click on local Windows debugger, it will not build the run swim folder. Instead, it will build some other folder, or you would get this particular error. Okay, because when I click on the play button or local Windows debugger, it will try to run all build, and we don't want to run that. So I will click on the drop down menu, and I will click on configure startup project. So we don't want to run the all build project. Instead, we want to run the run swim project. Okay, and this project is going to create a .exe file, and therefore we will be able to run the application and test it. Okay. If we click on SWMM5, this particular project is creating a .dll file. Therefore, we won't be able to debug the application. So if we want to debug that particular application or the project, what we might need to do is we might need to, let's say you are building a Python library which uses SWMM5 project, the DLL produced by SWMM5 project. And what you will have to do is will have to run the Python project and attach that project to this particular ID. And when that particular um, breakpoint is hit, so this is a breakpoint. So when a particular breakpoint is hit, uh, the debugger will show all the values. But yeah, that is complicated. But for simplicity, we will go with runswim because we have that particular project inside our solution. So I will just run SWMM. So I will select run SWMM. I will click apply. Okay. And yeah, now let's see what happens. Okay, so this is what happened. Okay, again I will click. Okay, and when I click on the run button, it started the application and it has paused at this particular point. Okay, now what we can see is in the locals window over here in the bottom, in the locals window, or what you can do is you can also go to view, and over here, let's see if we have locals window. Now the debug windows, let's see, most probably you will be able to see the locals window at the bottom. If not, you might try to Google search how to open the locals window inside Visual Studio Code. I think it should be somewhere over here. So if you click on one of these options, you should be able to see the locals window. I'm not able to find the actual option where you could click on the option and it will pop up the locals window. But yeah, there should be a way to do that. If this particular window is not visible, you can, Google search how to open the locals tab in Visual Studio, and you will be able to have your answer. So if I click on this particular button, it will take me to the next line in the code. Okay, if I click on this, so the most important thing over here is these two variables. So argc and arguments array. So argc is count of number of arguments which you will be giving. So when we run the command line application, we will be giving 4 arguments. One is the name of the application, and the rest of the 3 are the inp file path, report file path, and output file path. So those will be stored inside this particular variable. And then we will create 3 other variables called as f1, f2, f3, which will which will be input file, report file, binary file. Okay. So right now we are running the application, but in the debug mode, but we haven't told the application what is the path for inp file. Okay. If I click on next, next, next. Okay. Uh, if I click on this one, so it says major version. If I click on this particular variable, it says 24. Okay. And yep, release 4. These are versions. If you hit next, so yep, we'll just split the screen, close the Copilot window. Now the interesting thing will happen. So we haven't given any arguments to the file or the application. Therefore, it will hit this particular line because number of argument count is 1. 1 represents the name of the application. So that is when it will say not enough arguments have been given. And if I hit next, you could see this thing is getting printed. Okay, so which is basically this particular line in the code. And if I hit next, okay, it will return the code. So what is happening over here? Right. The issue is we are not giving any arguments to our project when we run it. Right. Hit the stop button, it will stop debugging. Right. The problem is we are not giving enough arguments to our project. And to resolve this issue, just click on the project, click on properties, go to debugging, and over here you need to give the arguments. So when we are running this particular project through command line, we are manually writing the commands. Okay, so I'll show you again. If I click CMD and if I click run SWMM, okay, I will get this error. If I'll do same thing, but with inp file dot rpt file and with dot out file, it will not give that error, right? Because I have given these arguments. What we need to do is we need to give same arguments to our debug application as well. So when we are running this particular application, we'll just right click properties, we'll give these arguments to our debug application as well. So I'll paste these arguments. So what the C application will do is it will split this particular text whenever it encounters a space. Okay. So if it encounters any space, it will split this particular text and it will consider this as one argument, this one as second and third. And there will be a fourth argument, which will be the name of the application, which is run swim. And that is something which we don't need to give because our debugger knows we need to run the swmm.exe file. So it will take that. Okay. And another thing is our working directory. So right now debugger assumes that it is running from the project directory, which is this one. Okay, build. But if you go and look at our file, so our inp file is stored under build. Then inside build there is a folder called as debug. Okay. Therefore, we need to tell our compiler or debugger that it is not inside build folder, but folder further inside called as debug. Okay, I will just search debug over here and okay, I'll just add it. Now I'll remove the extra slash. Yeah. So now it will know that our application is inside the debug folder because we have added the configuration as well. This configuration variable represents the mode in which we are running our debugger. So for example, I'll just click OK. Okay. So right now we are running this in the debug mode, but we can run this in release mode as well. If I go right now, if I click over here, debugging, if I go to this particular location again. So now we haven't run our project yet, but if we run, the configuration will turn to uh, build, I guess. I feel that should be the case. Okay, I'll go back to debug. So now if I run the project and I'll just close this. If I go back to my project and if I hit this debugger, I'll see the input file will have some value. Mm, Okay, let's see. So now we have just initialized those variables. I'll hit next, 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 next. Now, earlier it was, hitting this particular line because this condition was true that the number of arguments were one, but now, nope, that is not the case. Because what I can do is I can copy this particular variable name and I can go to intermediate window, paste it, and I can hit enter. Once I hit enter, it returns value 4, which means there are total 4 number of arguments. Now, again, it is checking another condition. If number of arguments is 2, uh, then which means if we haven't given the name of output file and RPT file, it will run this particular part of the code. That is not the case. We have given all 3 parameters, which is input file, RPT file, and out file. I can just run through them. Okay. This is the line where the actual magic happens. So this is a function called as run swim, and when we run this particular function, it will execute our uh, simulation. Okay, so what it requires is input file, report file, and binary file. And if I want to look deeper, what is happening inside this particular function, instead of hitting the next line using step over, I will instead use step into, which is I don't need to move forward, but I just need to dig deep into the source code of this particular function. So I can click that, or I can, there's another way as well. So I can use definition. So what it will do is it will create a small window over here to tell you what is the actual definition or what is the source code for this particular function. So if I do that, it will tell us what is happening inside this particular function. So what is happening is, okay, this is the source code. Yep. It will take three parameters, f1, f2, f3. F1 is input file, f2 is report file, binary file. Then again, it is opening the project using this particular line, and there are a couple of other things as well. But yeah, we will not go deep into that. I'll just close this, and again, I will step to the next line. Over here, you could see it says simulation completed. Uh, Now it will have a couple of other statements as well. So it has printed this particular line as well. Okay, and yep, done. So now I go to my application. I can see my application has been executed. So this is how you run your EPA SWMM source code using your custom application. So what I can do is I can also, open this particular file and I can just copy this part, okay, and paste it over here and just delete this part, okay. And again, what I can do is I can delete this part as well. Is it required somewhere else? Nope. Okay, I need to assign the variables as well, right? So yes, this part, okay. copy this part and I'll delete the rest of the part as well. And I will delete these variables as well because they are not required. What is required is, yep. So this is my application. So instead of using the predefined application, so I just need to run this particular function because I've hard coded the INP file, report file, and binary file. So I don't need the rest of the code because I have hard coded those things. But in production quality applications, you don't do that. You will have to have multiple checks and error functions to determine if something is going wrong or not. So this is not a best practice, but wanted to tell you that instead of having the boilerplate code, you can write your own code, you can change it, you can add certain things, and you can run it as well. So now this is my application. This is not the boilerplate code. So this is just a uh, simple function which runs run underscores swim underscore run function, and I'll just run it. What I will do is before it hits the last line. Okay, so this is the application. What I will do is I will delete the out file and rpt file, and then I will just hit next, next, next. Now you will see when I execute this particular line, it will create the rpt file and the out file for the simulation. Okay, yes, so now it has created these two files. So this is how you download the SWMM5 5 source code, compile it, and build your custom applications on top of that, and use the debugging mechanism available in Visual Studio to debug your application. So thank you for watching video. Um, cheers. Bye.